Good morning, good afternoon, good evening, happy Hoops Day, whatever the case may be. You have tuned in to Lesson 6. And Lesson 6 will kind of look like Lesson 5. Lesson 5 was adding real numbers. Today, Lesson 6, subtracting real numbers. This should be a review for you. This is how we combine positive and negative numbers together. We keep track of the signs, make sure we get the right answer. And I want to help you a little bit, make it a little bit visual today. We're going to be using, as it says, real numbers. And if you remember back to lesson 1, where we're dicing up the numbers into different systems of numbers, real numbers included just about everything. It included all the rational and irrational numbers. So the best way that gets expressed is on a standard number line, where values heading this way are positive and values heading this way are negative, and got 0 or the origin right in the center. So we want to think about subtracting real numbers today in kind of a visual or a geometric format, because the rules that they give are a little clunky. Unless you can really think abstractly here at this point, the rules will just kind of be like, okay, if that's what you say. So I'm still going to go over the rules and give you a little bit of different vocabulary, ways they talk about it. But then we're just going to use the pictures, okay, to kind of help us with that. And just to make sure that you're okay with how you can use your calculator to verify stuff, there are a couple of different buttons with the negative thing on them. Mathematicians kind of drive me nuts to watch YouTube videos, and they almost always say -7 and -2. And I think that minus is an operation, like it means subtract. I'll take this minus that. The negative to me is a slightly different concept, though they're almost used interchangeably. I know I was just blah, 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 but here we go. Okay, one of their new concepts is talking about the opposite of a number. And what we did with natural numbers and counting integers when we move from natural to integers is we start off with 1, 2, 3, 4, etc. And then we included all of their opposites. That is like their mirror image on the other side of the number line. Okay? So the opposite of 1 is -1. The opposite of 2 is -2. It just says what's on that side. It's the same distance away from the origin, but it's off to the left rather than to the right. And honestly, addition, anytime you've got addition, you're thinking about pointing that way. And then anytime you got subtraction, you're thinking about going that way. Another term for opposite would be additive inverse. The additive inverse of something. And that is you'd be adding, but you'd be going in the opposite direction. You're taking steps in the other direction. This is useful for something like physical science when we just kind of stay here and we go, we're going to take 2 steps forward, and then we're going to take 3 steps back, and where do we end up? We're 1 behind where we started from. Okay? So I think the number line's pretty handy that way for seeing some of this stuff. If you just got the numbers and the symbols, you start to kind of like, how many negatives do I need and how many are working with here? Their rule in the book is the inverse property of addition. The inverse property of addition. And this is one of those like, how do I get back to where I started from types of problems. The rule is stated this way. If you've got a number, and we're going to call that number A, and maybe that seems weird, but we're going to represent it in a general way. If you've got a number A, here's the rule. A plus negative A is the same thing as taking negative A and adding that to A, which is the same thing as getting back to the origin. Okay, now think about that as in terms of what we've got up here. If we didn't have these numbers and we just had like A and twice of A and 3 times of A, over here we'd have the opposite of A. And so if I take a and I add to it how far we'd have to go for negative a, we end up right back here at 0. Or if we went this way first in negative a steps and then back a steps, we get back to 0. Okay, that's all that's saying. So if we want a number, if we start with a number and we combine it with its opposite, they like cancel each other out and we get back to 0. Now, how's this related to what we're supposed to be doing here? Subtracting real numbers. Give me something real, right? Give me a real number like 5 or 10 or something like that. Okay, fine. The rule for subtracting real numbers is that to subtract a number, you add its inverse or its opposite. Then follow the rules for adding real numbers. That to me is a little clunky. That to me doesn't really get to the guts of what we want, but technically it's correct. That's only if we want to get back to where we started from. Okay, so there's some properties there. We can reverse the order of things that we do to make it easier. If you want to start off with the positive and then go with the negative, I usually pick whichever one of them is the bigger one and I put it in front. For instance, here's what I'm talking about. If I've got the problem 21 minus 13, technically I could think of that as 21 and the opposite of 13, which is kind of silly because that original problem is not so bad, okay? But what if the problem was switched around? Let's just say it this way that they say the opposite of 13 and 21. Okay. That, if we're going to think of it on the number line, this would be going 13 in this direction. We'd end up at negative 13. And then we're going to go 21 in the positive direction and thinking where we would end up. And putting those two together, if you went negative 13 that way and you went 21 back this way, you end up on the positive side at positive 8. Okay, but we're subtracting. So what if it was this? Well, that silly little rule says the first thing that we could do would be to add its inverse. Okay, so think of it like this, plus negative 21. Maybe this makes more sense because here we've got a negative and we got another negative, so we're going negative 13 in this direction, and then we're going to negative another 21 in that direction because that's the negative direction. So I'm going to add the opposite. The opposite of 13 and the opposite of 21 is the opposite of 4, which are all Fibonacci numbers. Huh, see how much I like numbers. Okay. The opposite of 13 and the opposite of 21. Just kind of tuck away the opposites for now and just say, well, I'm going further that way. 13 and 21 is 34. It's the opposite of those real numbers. It's the opposite of the positive version of those real numbers. I just added them. This may sound weird, but this is kind of the way I think about these things. Really, subtraction doesn't really exist. If we're just talking about straight up algebra, okay, what does exist is the addition of opposites. Okay, I'm going to add a negative. I can always write a subtraction problem as adding a negative. That way I kind of like can take away the signs for the moment and just think, well, opposite means it's going to get smaller, or the opposite of an opposite would be me doing this. I'm going to do the opposite. Wait. No, I'm gonna do the opposite of the opposite, and I'm gonna go this way. You think of it in terms of positive and negative directions, and then what's the opposite of going in the negative direction? The negative of a negative is positive. Does that make sense? The opposite of going in the opposite direction is going in the right direction. So I think the problems are pretty straightforward. They're going to give you subtraction problems. They're also going to ask you to subtract negatives, like that problem here. Like one of the first practice problems is 14 minus parentheses negative 22. If you want to think about it in the number line, you're like, I'm over here at 14, and then I'm going to add the inverse of negative 22. Yeah. Or you can say, why don't I just rearrange that? This is also true. You know that a negative times a negative is a positive. There you go. 6. But anyway, you could have done that right here. The negative, subtracting an opposite would be just doing the normal addition in that direction. Okay, your calculator knows how to do these, but let me tell you about that one thing I was saying where we want to keep track of these things. If I want to type that out the exact same way, 14, here's the minus sign, there's the subtraction sign, and then I do need to use parentheses. They can be found right up here above the 8 and the 9. So I'm going to use open parentheses, and then the sign for negative is down here next to the decimal point. These, the negative and the subtraction sign will do different things. The calculator knows that. So you'd want to put a negative inside the parentheses, 22, close those parentheses and hit enter. If you do like, if I do that again, I go minus, and then put in there minus 22. It doesn't like that. It says that's not okay. So the first one, it will give you an answer, but the second one, it won't. It does not appreciate that type of business. In addition to that, if I went 14 and I went negative, negative 22, then it does multiplication. So there I just used the negative sign twice, and that gets me the wrong answer too. Always, 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 will you please make a prediction before you do the problem? Take a guess as to what type of answer you would get. First of all, is my answer going to be negative or positive? And then kind of a ballpark. It should be around 10 or it should be around 30. And so if you get an answer like positive 308, please don't just write that down. Use your noggin and think about if that makes sense. Okay, does this answer make sense in the context of what I'm trying to do today in my work? I think that should give you enough to go on. Okay, if the positive number is bigger than what you're subtracting, then your answer is going to be positive. If the subtracting or the opposite number is bigger than the positive number, you're going to get a negative number. I think you can figure it out. We'll talk about this. Okay? Talk about this.